Morning, guys. We're going to start quite easily with some algebraic fractions. We'll start with examples on simplifying. The techniques that you need to learn are based upon exactly the same as what we do with normal fractions. The purpose is to use a single division sign with simple expressions top and bottom as much as possible. So I'm going to run quickly through some sections. The easiest one is when we do multiplying fractions. So if I have two fractions and I want to multiply them, those who are used to pre-cancelling, doing it first, have a bit of an advantage. So if I give you a fraction 15/20ths, of course you're going to share both by 3. That cancels out to give us what is 3 by 5, sorry. What is 3 over 4? And that's the idea we're looking for, is cancelling early. If we separate out into two separate fractions, say 3/8, and we are going to multiply by 6/7, we can do the pre-cancel step. You don't have to multiply them through and then look for factors. Early factors is useful as well. So both of these will share by 2 and then multiply through to give us 9/28. Now normally if you pre-cancel correctly, there will not be anything to simplify. When we come to the algebra version, we need to check it. Now let's do a couple of examples of what goes on, and I'm going to do a relatively difficult one so that you can actually see the process and some of the benefits. So let's go for so if I've got a squared plus 3a plus 2, all shared by 9, you would see if there are any common factors and cancel them. But if this is going to be multiplied by a second one, which is 12 over a plus 1, you should be able to recognise quite quickly, yeah, there's at least one factor, and the factoring step, and that is in cancel both by 3 to give me 4 and 3. The second part is have a look at the other ones. Now we've got a quadratic here, and we need to think, does it factorise? So we'll look at the parts, and you should hopefully, generally with these, the factorisation is fairly clear for most exam questions as well. You shouldn't have to do too much difficulty. They want to know the technique is done. So when we look at the two parts, I've got one potential factor, 2 and 1 make up the 2. When you multiply, add them together to give the 3. So my two factors are going to have 3, a and 1. Check the signs, both positive signs, so they're both positive terms. Okay. If this was a negative, of course, one of them would be negative. If that's positive, the bigger one is positive. If it's negative, the smaller one is negative. And if this is positive, but that's negative, these are both negative signs. Those are the tricks to look at. Now we look at the two expressions, and we realise that we can do another pre-cancellation. A times 1, and then divide by a times 1. Now there is one thing which is a little bit more than what it says in the book. If you do that cancellation, what it actually means is whatever we get on the right hand side cannot describe a plus 1 is equal to 0. So we cannot say anything a is minus 1. we're not allowed to say anything about that situation. So that leads to us actually saying whatever we produce on the right-hand side doesn't describe a situation when A is -1. But it's exactly the same function for the other two, all other places. So what we've got is we've got 4 multiplied by the a plus 2, and on the denominator we've got 3. If you're simplifying fully, expand the bracket as well. Often expand the brackets as well, because you might get a complex set of terms on top. And if they do, you can wind up having a problem that there is a further factorization can happen. With the algebraic ones, you can, even if you do good pre-multiple cancellation, when we come on to adding and subtracting, you will get problems where you have to be able to do the second part. I'll do a second example on this. Hopefully it's not going to be a surprise to you, but we'll do a quick example of a division. It is the same ideas, so I'm just trying to get the screen to scroll. And the question we're looking at for this first part is, that one is this one. What happens if, there we go, 12 divided by x squared minus 1 shared by 4 over x plus 1. You might even see this as a a fraction with a fraction underneath. It sometimes appears in exams like that. Just rewrite it as a division sum along the way. Okay. So what's the rule we do when we are dividing? Well, the rule is keep, change, flip. Keep the first fraction the same way up. Change the operation to its inverse and do the reciprocal of the second. Flip the second fraction. That's a reciprocal. So that's keep, invert, proper maths, and reciprocal. Now we look through, the 12 and the 4 cancel, give me 3, and then we've got x squared minus 1, which from our, we know difference of 2 squares, dots, difference of 2 squares tells us we've got 2 brackets here, where the square root of the first bit and square root of the second part, ignoring the minus sign, are both in the brackets. And then when you come to multiply out, the constant part is negative, so we've got different signs. That's dots. We check our 2 expressions, so I'll put a bracket around that one, and we get a cancellation of x plus 1. And this leads us to 3 times 1, all shared by x minus 1. Okay, that's as simple as it can get. You can't really do too much with that bottom part. That's the first part of the video. It's all to do with the sections. If you've got the textbook, you can have a look at exercise 1A. I don't expect you to do loads of these mini exercises, but the big thing is as we get towards the end, and once I am able to say we're able to do things a bit quicker, what I expect you to be able to do is the chapter show that you've done the chapter review completely. So what we're looking at is exercise 1A, page 3, exercise 1A. Check the answers in the back of the book. If you haven't simplified far enough, try and work out why. If not, come back to me and give me a quick shout and I'll try and sort out